Alright, so here we go. I'm going to give you a little help on that take-home assessment. We'll start on 286. Flip through my book here. 286, 1 to 18. Okay. 286. So you're evaluating some integrals here. The fundamental theorem of calculus. So let's say number 1. Okay. So number 1 is the integral from 1/2 to 3 of 2 minus 1 over x, 2 minus 1 over x dx. So ultimately, if you graphed this curve and looked at the area between that and the x-axis from x equals 1/2 to 3, that's going to be your answer. Short way to do it with fundamental theorem of calculus is find the antiderivative of the yellow thing, or an antiderivative, like, right? So antiderivative, we're looking at 2x minus the natural log of absolute value of x. So there is your antiderivative. We're going to evaluate that from 3 to 1/2. So your answer is going to be 2 times 3 minus natural log absolute value of 3. Take away 2 times 1/2 minus natural log absolute value of 1/2. Okay, we're using the fundamental theorem of calculus that says, hey, the area under f of x with respect to x from a to b is antiderivative at b minus antiderivative at a. So as far as your final answer goes, you clean this up a little, so you got 6 minus natural log absolute value of 3, take away 1, add natural log of absolute value of 1/2. So 5 minus natural log absolute value of 3 plus natural log absolute value of 1/2, and I'd leave it there. You could go ahead and figure that thing out as a decimal, but you can leave it there. So if you look in the back of the book on this problem, the answer looks a little different. And you wouldn't have to go ahead and do this, but in case you were curious, if you remember, the natural log of a over b is the natural log of a minus the natural log of b. So you can split that piece in yellow up, so it would be the natural log absolute value of 1 minus natural log absolute value of 2. So you got 5 minus natural log absolute value of 3 plus natural log of 1 says e to what exponent equals 1? Well, that's 0. So that goes away. So your final answer is, let's see, 5 minus the natural log of 3 minus the natural log of 2. And we'll check that in the back. 5, 4. Five minus the natural log of 3 minus the natural log of 2. So final answer would be here in blue. But hey, big idea here was you're using this guy right here. That's a definite integral, right? There, a and b are there. It's asking about area, and that's the shortcut. Find the antiderivative, plug in the upper, plug in the lower, and it's upper minus lower. Alright, next section of problems. So that's 286, 1 to 18. Let's look at 14. You know, 14 is the same concept, but we'll look at it. So 14 from page 286 is the integral from 0 to 4, 1 minus square root u over square root u du. So this one, I think this one will be, this one's tougher because it's harder to see what the antiderivative is. But we can do it. So let's say I'm going to take a stab here at the antiderivative. Okay, what if the antiderivative was 1 minus square root of u to the, let's see, we'll go with, let's go squared. Okay, so if I took the derivative of that, that would be 1 minus root u to the first times the derivative of the inner. Okay, well, what's the derivative of 1 minus square root u? Okay, the derivative of du of 1 minus square root u. Okay, well, the derivative of 1 is just 0. So it'll be 0, take away. Okay, that's u to the 1/2. So it would be minus 1/2 u to the negative 1/2, which is negative 1 over 2 root u. Okay, so if you cleaned this guy up, so the derivative of that, if you simplified this, okay, these 2's would go away here and here. So you'd have 1 minus root u over root u times negative 1 times negative 1. So how are we going to get rid of that negative 1? Well, if you go back up here and you insert a negative 1, then those will cancel out. So here is what we were looking for. So we found the antiderivative. So I'm going to get rid of this work here. Delete. Okay, so it asks us about area. Notice there's boundaries there. So, okay, I need the antiderivative. Well, the antiderivative is negative 1 minus root u squared. Evaluate that from 0 to 4. So when you plug 4 in, what does it look like? Negative 1 minus square root of 4 squared, take away negative 1 minus square root of 0 squared. Okay, so here's the piece with 4. Okay, big F of the upper, big F minus big F of the lower. So we clean that up and we go negative 1 times 1 minus 2 squared. Those will make a plus, so plus 1 squared. So negative 1 squared plus 1 squared. That's negative 1 times 1 plus 1. So negative 1 plus 1 equals 0. So the answer is 0 for 14. So, okay, next it was 37 to 42. 287. 37 to 42. Number 37, page 287. Okay, so you're dealing with integral functions, right? Y is an integral function in 37. Okay, this could be written as y equals or y of x equals. Notice, though, the input of this function has to deal with the boundaries on the integral, right? Specifically the upper bound on this. So when we did this in class, I'd ask you, like, I say, okay, just plot if you're going to graph this integral function, plot points, right? So you'd say when x is negative 1, when x is 0, when x is 1, when x is 2. So you get an idea of what this graph looked like. And then I'd say, well, what about when it's x? Okay, how much should this be over here? Well, if that is x, most students are saying, okay, well, if you're going to find area, under a curve, because all these values over here would be area values. If you're going to find area, you got to go antiderivative, plug in the upper, plug in the lower. So think, if you take this let's find the antiderivative of that. Let's see, that's going to be Well, we'll take a guess at it, right? I wonder what the derivative, let's see, right now that's a square root, so the old exponent would have been 3/2. Okay, would that work? Let's try that. I don't think this is the one we're looking for. That will not do it, because that's going to produce 3/2 1 plus t squared. 1 plus t squared to the 1/2 times 2t. And I don't have a 2t there. Okay. Alright. What do we got? What do we got? So that's not the correct antiderivative. So you're thinking, if I can't find the antiderivative, oh my gosh, how am I going to do this? But it's okay. Watch this, okay? So you were trying to find the antiderivative of the blue thing, correct? Hopefully you said yes. Yes, I was trying to find the antiderivative of the blue thing, and then I'll plug in the x, and I'll plug in the 0, and, da-da-da. That's the way I'll go, okay? Let's call that blue thing right there. If you don't mind, let's say we got this function, right? Function of t. Little f of t is the square root of 1 minus t squared. Okay. And remember, like, you're trying to find these areas here, okay? Trying to find those. Like when x is 2, you're going, okay, that's, when x is 2, that's the integral 0 to 2, square root 1 minus t squared dt. And we were going to compute that, right? And granted, I still, like, okay, I could do that. I could do that if I could find the antiderivative of this, but you're telling me that's hard to find. Yeah, it is hard to find for this problem. And this problem is a little different too, because they're not asking us for these values, right? They're asking us for the derivative of this function. So, nonetheless, so let's say we were trying to fill out what's in yellow there, okay? So what's in yellow there, if that's little f of t, what's in yellow would be big F of 2 minus big F of 0. That would be big F of 2 minus big F of 0. You're like, well, how much is that? Well, I don't know how much that is, but that's what it would be. What about x? Right? What would it be for x? Okay, it would be, if that's little f of t right there, it would be big F of x take away big F of 0. Right? Antiderivative at x minus antiderivative at 0. I'm not telling you anything you don't know. You're just probably a little confused because you're wondering, how in the world does that help us with this problem? Okay, so if you don't mind, I'm going to rewrite y of x. Okay, y of x is equal to, another way to write y of x is big F of x minus big F of 0. So if you take the derivative of both sides, you get y prime of x, or just y prime. Okay, the derivative of big F of x. Okay, the derivative of big F, so the derivative of the outer, the derivative of big F is little f. The derivative of the outer evaluated at the inner times the derivative of the inner. Well, what's the derivative of x with respect to x? Just 1. Okay, minus the derivative of the outer. Okay, so the derivative of big F is little f at the inner, 0, times the derivative of the inner. What's the derivative of 0? 0. So that piece drops away. So y prime of x is equal to f of x. Well, okay, wait. F of x. How am I going to get f of x? Well, here's what f of t looks like. That's your function when you plug t in. So here's what your function looks like when you plug t in. When t is your input, you go square root of 1 minus t squared. When x is your input, instead of t, you'll have square root of 1 minus x squared. So y prime is just f of x, right here. Square root of 1 minus x squared. We'll do another one. Let's say we did 42. 42. You're dealing with an integral function. Okay. So there are times when you take the AP test and you go, okay, I think I need to find the derivative of that integral function. How did we do that? So we want y prime. Okay, that's what y equals. Is there another way to rewrite y? Well, sure there is. This is an integral function. How do you rewrite that? Well, if you actually wanted to compute that, you just do the antiderivative of the blue thing at cosine x minus the antiderivative of the blue thing at sine x. So we don't have to do it. You don't actually have to compute the antiderivative of the blue thing. Okay? Let's say you did. You'd say, okay, it's the antiderivative of the blue. Okay, then that's 1/3 t cubed. And let's say like student A says, you know what, I'm going to compute the antiderivative and I'm going to evaluate it at cosine x and sine x. That's basically what y is. And the other student says, okay, so student A says, you know, I'm going to find an antiderivative of the blue thing, and I'll plug in cosine x, and I'll plug in sine x. So what that would look like, so y is equal to, you're rewriting the integral function using fundamental theorem of calculus, integral a to b, f of x dx is big F of b minus big F of a. So you're just using that. So that would be 1/3. So cosine x cubed cos x cubed minus 1/3 sine x cubed. And they're like, sweet, I got y. But you're not done. You notice it asks you for dy dx. It asks you for y prime. Well, here is y. How do you find the derivative of y with respect to x? Well, you take its derivative. So you just come here. So the derivative of y prime equals, so you take the derivative of, you can do these in two parts because they're subtraction. So we have, let's see, 3 times 1/3. So this would be 1/3 times 3. The new exponent will be squared. The inner is cosine x, and the derivative of the inner is negative sine x. Minus 1/3 times 3. New exponent is 2. Derivative of sine is cosine. Okay, you can clean this up a little. Those go away. So you have cosine squared x. We'll have it times sine x. I just moved that negative right there. Minus sine squared x cosine x. That's your answer. That's it. I say that's it like it's easy. I mean, it's the fundamental theorem of calculus. It's not easy. So let's say you took a different approach. Okay? So fine and dandy, this is your answer. Okay? You'll notice that first problem I did, I wasn't able to find the antiderivative of the blue thing, but I still was able to complete the problem. So we'll parallel it here. So you're sitting here. Okay, that's my integral function. What I have in blue, I'm going to call that's f of t. some function involving t is equal to t squared. I say, what's the antiderivative? Well, the antiderivative of little f of t is big F of t. Okay. So this is y is equal to big F of t sine x cosine x. You'll notice in the last one, in kind of version 1, big F of t was 1/3 t cubed. So this would be equal to big F of cosine x minus big F of sine x. Which, if you were trying to find, like, let's say y sub 1, that really wouldn't help you. You know, because you'd be looking at big F cosine 1 minus big F sine 1, and you'd go, I don't know what big F is. But the goal is to find y prime. So what's the derivative of y? Okay, derivative of y is y prime. Equals. Well, what's the derivative of this? Well, the derivative, so this is chain rule. You got the outer, inner, outer, inner. You got subtraction, so you can separate it. So the derivative of the outer, derivative of big F is little f. Little f cosine x times the derivative of cosine x, which is negative sine x. Take away derivative of big F, little f. So little f sine x times cosine x. Okay, we're not there yet. Well, what is little f of cosine x? Well, here's function little f. And that's what it looks like when you plug in t squared. So what does little f look like when you plug in cosine x instead of t squared? Well, instead of having t right here, you're going to have cosine x. So this would be cosine x squared times negative sine x minus sine x squared cosine x. That's y prime. And you'll notice that that is identical to our answer here. The format of them looks different, but they're the same. Those two answers are the same. Okay, so that takes us, we'll go to the next section. So that was 287, 37 to 42. So now 298. These ones will go faster. 298, 15 to 29. 298, 15. Okay, 15. The integral negative 2 to 2, 5 dx. Okay, this problem is just asking you about area. Okay, what's the antiderivative of 5 with respect to x? 5x. So you got 5x, negative 2 to 2, 5 times 2 minus 5 times negative 2, 10 minus negative 10 is 20. Okay, so that's big deal, 15 to 29. So 15 to 24, 15 to 29, they're all the same. Look at like 28. Let's see, 28. The only thing that's harder about 28 is the antiderivative. 1 minus x squared dx. So, you got to compute the antiderivative of the thing in blue on 28. So I'm guessing it's, I don't know what, the derivative of what is sine? The derivative of sine is cosine, so the derivative of negative cosine, so check. What's the derivative of negative cosine of 1 minus x squared? So I'm trying to form the antiderivative. Well, that would be sine of 1 minus x squared times 2x. Oh, no, times negative 2x, because the derivative of 1 minus x squared is negative 2x. So what's wrong with that? Well, I have a positive 2x here, not a negative. So I'll just put a minus 1 in here, multiplication. So then I can put a minus 1 in here, and these two would cancel out, and I found my antiderivative. So 28 will just be, let's see, those two make a positive, so it'll be cosine of 1 minus x squared from negative 1 to 1. You just plug them in. Okay, now we go to, that was 298, 299, and we did 15 to 29, and then 39 to 46. Okay, 39 to 42 is more integral functions. Let's say I did 41 on page 299. Page 299, number 41. You're given an integral function. T to the 4 dt. So we're asked to find y prime. Okay, y prime equals question mark. Well, I'm going to rewrite y. So y is equal to big F of 1 minus big F of x. Okay, y prime is equal to little f of 1 times 0, like derivative of the outer at the inner, times the derivative of the inner. Well, the inner is 1, its derivative is 0. Take away derivative of the outer, little f, at the inner, times the derivative of the inner. Okay, derivative of the inner is, well, the inner function is x, so its derivative is 1. So that goes away, so y prime equals negative f of x. Okay, well, what's function f look like? Well, this is f of t. F of t equals 6 over 3 minus t to the 4th. So f of x is 6 over 3 minus x to the 4th. So negative 6 over 3 minus x to the 4th. That's dy dx for number 41, 299. Okay, and then we have, let's see, I went 40, 30, 39, 46. I'm going to hold off on 43, 44, 45, 46. We can talk about those in class. Let's go to 356 now. Page 356. Alright, we're zooming ahead in the book. 356. Okay, 356, 5 to 8. We're looking at differential equations, finding the exact solution. So let's say we did number 6. Okay, in number 6, we have y prime equals x, 1 minus y, initial condition y sub negative 2 equals 0. So this is the same here as saying dy dx equals x 1 minus y. So you're going to solve the differential equation. And their language is find the exact solution. So you're finding the particular solution to the differential equation. Separate the variables. So this is dy over 1 minus y equals x dx. And then you can find the antiderivative of both sides. So the left side is natural log, so I'll integrate. Natural log of the absolute value of 1 minus y times negative 1. Because if you differentiated this, you go 1 over 1 minus y times the derivative of 1 minus y with respect to y. Well, that's got, derivative of negative 1. So you need that extra negative 1 there to cancel that out. Because you'll notice this is a positive 1. Okay. So, we found the antiderivative of the left, antiderivative of the right, x squared over 2 plus c. Divide both sides by negative 1. Natural log absolute value of 1 minus y equals negative x squared over 2 plus c. Let's see, I'm going to make some more room here. Okay. I think next step we're going to exponentiate both sides. Strip off natural log. So absolute value of 1 minus y equals, that can be separated as kind of two pieces, right? E to the negative x squared over 2 e to the c. Get rid of the absolute value. Put a plus or minus here. That's just still c. So you got 1 minus y. 1 minus y equals c e to the negative x squared over 2. Okay, I'm going to, minus 1 from both sides. Okay, now I'm going to multiply both sides by negative 1. Make that a positive y. Make that a negative c. That's still going to be c. Make that a positive 1. So we got y equals c e to the negative x. Oops. I'll write this as negative 1 times x squared, so you don't drop a sign, over 2 plus 1. Now you got to use your initial condition to find c. So let's see, y, when x is negative 2, y is 0. X is negative 2, 0 equals c e when x is negative 2. So negative 2 squared will be 4. So 4 times negative 1 is negative 4. So this will be e to the negative 4 halves plus 1. So I'll move the 1 over to the other side. Let's see. So I got negative 1. Negative 1. Y sub negative 2, 0. Okay, negative 1 equals c e to the negative 4. Well, negative 4 halves is negative 2. Okay. Oh, we're good. Okay, I was freaking out. Thought we did something wrong. So isolate c. You'll divide both sides by e to the negative 2. Divide by e to the negative 2. So you got c equals negative 1 over e to the negative 2, which is negative e squared. Hooray. So this isn't the final answer, but you found c. So that's got to go get plugged back in right here to get your final answer. So you got y equals negative e squared times e to the negative x squared over 2 plus 1. You can use properties of exponents then to clean up this, right? Same base right here. So that's going to be, let's see, y equals, so that negative, I'm going to write that negative 1 times e. Now we should add those exponents. So the 2 plus negative x squared over 2 plus 1. So final answer, we're going to put in yellow right here. I haven't checked that on Wolfram yet, but the process seemed like it was good. We'll see if we made some little silly sign mistake. You might type that into Wolfram and have it solve the differential equation, and you're like, oh my gosh, you're wrong. And maybe, but there's a good chance that our answers are equivalent. They just look a little different. Okay, we got time for one more problem. That was 356. Now let's go to 358. 358, 9 to 28. Okay, 358, 9 to 28. Well, 9 to 20, you're just doing, you're finding antiderivatives. And for some of those, you're going to be using U substitution. I'm looking at a couple of them right now, and I'm actually thinking I'll have to cross a couple of them off the list because they use integration by parts. So 358, 9 to 20, I'll cross a few of those off because we're not going to do integration by parts until after the AP test. 21 to 20. Let's see, 358, 9 to 28. So 21 to 28 is just differential equations, separation of variables. Then we go to 371. 371, 1 to 16. Okay, let's do number, I don't know, 6, 371. Oops, page 371, number 6. Okay, we're given velocity. V of t equals square root 4 minus t from 0. So t is going to range between 0 and 4. Okay, so A says determine when the particle is moving to the right, to the left, and stopped. Okay, well, particle moves to the right when velocity is positive. It moves to the left when velocity is negative. So if this is your velocity function in number 6, and you can use a calculator to help you on this one, as t ranges from 0 to 4, this thing is always going to be positive. Right? So if you think about all the values you can plug in for t between 0 and 4. Well, if t is 0, the velocity is square root of 4, so 2. If t is 4, the velocity is 0. So the velocity is only 0 at t equals 4. So v of t is greater than 0 on the interval from inclusive 0 to exclusive 4. V of t is never less than 0. V of t equals 0 when t equals 4. Okay, right, left, and stopped. So this is when it's moving right. Stopped is never less than 0. Never moving left. So you can use your graphing calculator on this. Just look at the function, right? And when your velocity function is above the x-axis, it's positive. When it's below, it's negative. So that's A. Find the particle's displacement is B. So displacement is just like if So let's talk about displacement and distance covered. So if here's where I start, and let's say I end here. So if I move forwards and then backwards and then forwards and then backwards and then forwards, my displacement is just this distance, okay? The distance between those. Your position at the end minus your position at the start. Now distance would actually be all of those guys added together. So that's my hint for you there. Now how do you turn velocity into displacement or distance? Well, the area underneath velocity is going to tell you about distance. So in some of those problems you're going to have to do multiple integrals to complete the task. So there's my hint for you on distance versus displacement. We'll come back and I will help you more tomorrow.